Okay, you're given a function in terms of sine, and p of x represents a third degree polynomial, and they want you to find p of x. Okay, so because this is not centered at 0, we cannot work off of the sine function that we know, so we're going to go ahead and come up with the derivatives first, and since I want the third degree, I'm going to go ahead and get up to the third derivative. So let's make my little table. So here's my function, and then I'm going to go through and calculate the derivatives first. Don't forget your chain rule on the angles. 5 cosine 5x plus pi fourths. Second derivative, negative 25 sine 5x plus pi fourths. And the third derivative is going to be negative 125 cosine 5x plus pi over 4. And it does say I want it to be centered at x equals 0, so I'm going to plug in x equals 0 for all of these, and these are my values that I get. Okay, so my third degree polynomial is going to be root 2 over 2 plus the first derivative times x, the second derivative times x squared over 2 factorial, and the third derivative over x cubed over 3 factorial. That's part A. Part B is find the coefficient of x to the 22nd. Okay, so you have two things. You can either calculate the 22nd derivative, which I really don't want to do. Okay, so I need the 22nd derivative times x to the 22nd over 22 factorial, and really what they're asking you to do is can you just come up with the coefficient, which is the derivative, don't forget, divided by the 22 factorial. So what you're looking for is a pattern in all your values that you have. So first of all, look at your notice first of all, if I go back to here, notice all your derivatives have root 2 over 2 in it. The only difference is these numbers in the front. First of all, notice that this is 5 to the first. Your second derivative has 5 to the second. Your third derivative is 5 to the third, so your 22nd derivative will have 5 to the 22nd. So this is going to be 5 to the 22nd. I have a root 2 over 2 on all of them, and then I need that 22 factorial on the bottom. The only other thing that you need to figure out is this number going to be a positive, negative? It goes starting with the first derivative, it goes cosine, sine, cosine, then you repeat the pattern and count out just the different. So it goes positive, positive, negative, negative. Just count it out until you get to 22, and you will figure out that this is going to be a negative symbol. So this is my coefficient. Okay, part C. Use the Lagrange error bound to show that the actual minus the polynomial is less than 1 over 100. So they want to show them that the error bound is less than 1 over 100. So using the Lagrange error bound, the polynomial that I came up with in part A, remember, was a third degree polynomial. So your error is going to come from the next term over. So this is what you should be thinking. I need to somehow come up with the biggest value that the next term over is going to take on, which is this particular term. So let's figure out all the pieces. I'm going to plug in the x first. The x is what they plugged in here, which is 1 over 10. They told us it was centered at 0 from part A, so I have this. The only other piece that you're missing is what is this biggest value that the fourth derivative could take on? Okay, now you have to be really careful. This is a sine function, but notice when we took these derivatives, there is a coefficient in front, so you have to think about what is that fourth derivative. Your fourth derivative is actually 625 sine of 5x plus pi over 4. So we did talk about that the biggest value that sine and cosine will ever take on is 1, but you also have this coefficient in the front, so the biggest value of that fourth derivative is going to be 625. And when you punch this out, you're going to get 1 over 384, and there's my check. Yes, that is a number less than 1 over 100. Lastly, part D. Can you find g? And g is just the integral of the function f of t. Okay? So all I'm going to do is go ahead and rewrite the polynomial that I came up with in part A using t instead of x. So I'm going to just write the first couple terms. And I know that I only need to get to the second degree because when I integrate this, I'll get 1 degree higher. So to get to the third degree, I just need to have these terms. So when I integrate it, so I kind of did 2 steps in one. So when you integrate this, you will get root 2 over 2t, and then plug in the x, and all the 0 terms will drop out.